when we set out, we thought, okay, we want to empower companies to use AI in a better way, in a more reliable way. And what all of them do is they feed their own data into the models because they can't rely on what the model already knows, because typically the company internal data is not public knowledge. So they feed their own data, but they still see hallucinations. So we thought, okay, we're going to focus on these extrinsic hallucinations.
Do LLMs know well what they don't know? Or do they know what they cannot do?
I would say that's an almost philosophical question. So it's hard to tell, even for us, what the LLM thinks. But one thing's for sure, LLMs tend to not.
Human Future Hub Podcast, Episode 1, Hallucinations in the Wild, Conversation with Blue Guardrails by Ákos, Kádár. Hi, my name is Kata Spajchala, and I'm a co-founder of Human Future Hub. Today, I welcome you wholeheartedly to the first episode of our podcast. Let's start with who we are. Human Future Hub is a non-profit organization based in Berlin and Munich with global ambitions. Yes, we want to make it a global movement. And what do? We support people of all ages and all backgrounds in navigating this new landscape of AI by raising awareness, providing education and guidance. Our two main pillars of activity are future of work and future of education. And we also foster a community of humans, community of support, and community of curious people, AI realists. And that's why we also started this podcast to promote real view on AI capabilities and what we are dealing with in these times. Our podcast host is Ákos Kádár. Ákos is a machine learning researcher and engineer, and as a core team member of Human Future Hub, he contributes technical expertise to translate complex AI concepts into actionable knowledge. He holds a PhD in natural language processing and computer vision from Tilburg University and has developed AI systems at Samsung Toronto AI Research Center, Borealis AI, and Agile Robots SE, just to name a few. He also volunteered as a career coach for immigrants facing employment barriers. Today's guests are Miriam and Mathis from Blue Guardrails. They're both AI engineers with years of experience in building production AI systems. They started Blue Guardrails to focus on the quality and reliability of AI products. The work centers on identifying where systems go wrong, for example, when models fail to follow instructions or produce hallucinations. Their platform helps companies measure their issues, understand why they happen, and improve their systems so they behave more reliably in real-world use. So check them out. They are Berlin startup Blue Guardrails. Now, without further ado, onwards to the podcast.
So hello guys, you have a nice office. It looks really cool.
Yeah,
Thank you.
Thank you. It is very nice.
So you guys are working on hallucination detections. You guys are called Blue Guardrails. And so I thought that the first question that I would like to ask to you guys is like, how did you guys become interested in this actually? Why are hallucinations such an issue that there's a whole industry around it? And how did you guys become interested in it in the first place?
We both spent our careers as AI engineers and, different perspectives and in different positions. And we helped a whole lot of different customers to get their Gen AI ideas from, prototyping into production. And what we saw is that they all had great product ideas and great Gen AI products came out of this, but they all lacked the tooling to see what the quality of the Gen AI products actually was. So especially when those products went live, there was almost no visibility into the quality of the outputs, and they had no way of systematically observe if the tool is doing what it's intended to do.
Okay. So you're just, you're talking about quality assurance in general. And I'm wondering, what is the specific challenge when it comes to like hallucinations in these jobs that you have done, or like now that you guys are on this journey of like probably discovering how people are dealing with this, like what do you find? Like what are these kind of like everyday scenarios for businesses where it's kind of a little bit more than what quality assurance has typically been doing?
I think maybe like, I don't know, when ChatGPT first came out, like everyone knew about hallucinations. It was also non-tech people, like everyone would know about hallucinations. Hey, I can ask it who's the president, and it would answer with the last president instead of the current one and stuff like that. That was early on. And then people found techniques to work around it. Like, hey, I need to give current data to the model via search, for example. So I'm building something that in the industry people call RAG, so retrieval augmented generation. And this data is the basis for the answer from the large language model. And we saw this a lot, like let's say, for example, a legal chatbot for legal professionals who have questions about existing legislation or existing court decisions regarding a certain topic. And the system would retrieve all of that data from a database, but we saw that the models still made so many things up. Like there were still hallucinations where the model would say, oh yeah, this is stated in that paragraph, but actually it's nowhere to be found, or it confuses things from the context. And this was a problem that we saw essentially across all of the different applications that we worked on. So that's why we focused on it.
I see. So, but in these legal cases or like for legal companies, it seems like it's actually pretty bad because it causes like actual legal damages if they use LLMs to help their case, to have their research, and then they show up in court with false information that's actually against the law, right? And like maybe the cases get dismissed, so it's pretty bad for the plaintiffs also. Is this true?
With hallucinations, there are a few different problems that arise, basically. So one of them, of course, is legal repercussions. You know, if you state facts that are just untrue, you can get into legal trouble. But also in other cases, if your tool produces information that's incorrect, it will end up being a tool that's not useful for its users, and they will find out. And if you have a product that's unuseful, it will never materialize any ROI because people just won't use it, and they therefore won't pay for it. So that's another problem that comes from hallucinations and quality issues in general. And I think on top of that, for many companies, they run at the risk of reputation damage. So, you know, when it becomes public that your Gen AI application produces hallucinations, sometimes they get, media coverage that's damaging their reputation. So that's just another reason to really pay attention to that.
Yeah, it makes a lot of sense. I mean, I guess like by now, this kind of trust and reliability issues that you mentioned, like nowadays, like it's so common to just actually use the term like slop. I think these days it's like the term of 2026, I think, at the moment, when like even like a purely human-made thing that seems dodgy, we just call it slop at this point, right?
Yeah.
I guess it relates to what you were saying. I was thinking that you guys must have some sort of definition of like what these hallucinations in general are. Because you were mentioning false facts, kind of unreliable behavior. And I wonder, what is kind of specific about them? How is it more precise? How is it unrelated to other trust and reliability issues with Gen AI? Like, what is specifically, let's say, a hallucination issue that is not other issues?
I think that's actually a very difficult question. So when we started, I mean, I think there are a few accepted definitions of hallucinations. One distinction that people make is between intrinsic and extrinsic hallucinations. Intrinsic is when you just prompt the model directly and it states something that isn't true, which kind of needs external verification. Extrinsic is when you provide data to the model, like in a search setup, for example, and then it says something that is not supported by the data that you just gave to the model. So maybe let's say I talk about, I don't know, the last World Championship in soccer, and then the context says France won, but actually Spain, and the model answers like Spain won, and then that would be an extrinsic hallucination. And when we set out, we thought, okay, we want to empower companies to use AI in a better way, in a more reliable way. And what all of them do is they feed their own data into the models because they can't rely on what the model already knows, because typically the company internal data is not public knowledge. So they feed their own data, but they still see hallucinations. So we thought, okay, we're going to focus on these extrinsic hallucinations. We have data, be it an agent that retrieves context through tools or a RAG application. And we want to check, when does the model deviate from the data we passed into it? And then it gets even more difficult if you want to think about, for example, the prompt, the instructions, how a model should answer. Like, I don't know, answer in 2 paragraphs max, don't use complicated sentences and so on. That's the data you pass in, among other data. And then if the model answers in 3 paragraphs instead, is that a hallucination? Because it deviates from what you fed into the model. And we quickly figured out that we would say, no, it's more like an instruction deviation or poor instruction following. And we also saw that the hallucination umbrella isn't always that useful to describe these different phenomena. So actually now we have much more fine-grained criteria like instruction following, or also omissions. Like if I have an agent that should extract all side effects from a medication package leaflet, then if it forgets one side effect, that's an omission. You could say it's a hallucination, but we decided the more fine-grained analysis would be more productive.
Okay, that's really cool. Just to summarize it, like to check whether I understood what you were saying, you guys are focusing specifically on these extrinsic hallucinations, meaning when companies use their own data and then somehow the model manages to say stuff that is actually not supported by the data that the company. And you're saying this because this seems to be the majority use case. Like companies don't use raw LLMs; they use LLMs combined with their internal knowledge bases formatted in some way or another. Okay, and you're also saying that like along the way you kind of realize that they are separate issues. Like one is this thing that like the model is somehow just not saying things that are related to its context. But then you said that okay, technically the instructions is its context too. But somehow semantically, it doesn't really feel useful for users to think of the instruction as the context as well. So you decided that, okay, there's this instruction following. And you also said something about omission. I guess, would it make sense that like in larger umbrella terms, it's like completion or something? Because I personally often have this experience with LLMs when writing software, that it just loves avoiding things that seem like it cannot do. And I also wanted to ask you, like, do you guys know about this? Like, do LLMs know well what they don't know? Or do they know what they cannot do? Or like, is this something that comes up in your work?
I would say that's an almost philosophical question. So it's hard to tell, even for us, what the LLM thinks. But one thing's for sure, LLMs tend to not admit when they do something wrong. That's the one thing. At the same time, they'd like to say or pretend that what they're saying is completely correct and based and complete. So definitely there is an issue of, you want to call it maybe even honesty in the reply of LLMs, right? So there is its own reliability issue when it comes to completeness and complete groundedness of the answers in the provided data.
Yeah, I see. Yeah, I guess it's related to this kind of strange anthropomimesis that the developers doing, right? That they're like really trying to like imitate a kind of person, but this kind of person is like a little bit crazy, right? Like they're uber confident.
Yeah.
Like, it's not a person you would necessarily like in your everyday life, actually, right?
I think that depends. I mean, some people were screaming when OpenAI discontinued GPT-4o because they found a friend in it. So I think that's a like broader thing. But yeah, I view LLMs more as I don't know, they are a utility, not a person, not like a person. I want to use them for some task or purpose, and if they're not reliable, that makes them a lot less useful. And I think in coding, we kind of have improved the problem by a lot by introducing all these layers of verification. Like some layers already existed well before LLMs, some others were added on top of it. But basically, if you look at coding right now, a coding agent iterates. It's never one shot, it's always iteration. And then we have these layers, like in compiled languages, does it compile for other languages? We have like linters and type checking, the test suite. We have human review, like pull request reviews, where I think long before LLMs in development life cycles. So we have this whole like life cycle of verification layers that we now can apply to agents, and that helps make the output more reliable. But it's never like the output of just one LLM call. It's the output of a whole process of LLM and non-LLM things and people interacting to produce that output. And we think that this layered verification is completely missing in many other domains, which prevents productive use of LLMs in these other domains, like life sciences, for example. Of course, there are some players emerging, starting to do things with LLMs, but the potential is just so much bigger than what we have today.
And do you guys read this as, like you were saying that like there's an LLM, but then it's wrapped in like many layers of verification, and you were mentioning all these different kinds of best practices of decades of software engineering, and we have all these tools, and like we always had all these tools, like mathematicians or whatever, or physicists, like all these tools that help us because we can't think so far, right? And like now we're rather than wrapping it around us, wrap it around LLMs. And does this tell you that there is something fundamental in the way we train LLMs, that they will always hallucinate? Or is that problem going to go away at some point? Or do we need a fundamentally different technology that does not have this quality?
Well, I think the difference is that for coding tasks, these almost programmatic verification steps already exists, and now it's easy enough to wrap them around agents, as you said. For any natural language tasks, and that's what most of the other industries do, we don't have these verification layers at all. So the way we verified information that is language was by using our brains, right? We didn't have any rule-based testing suites or anything like that. So that makes it so much harder to verify the outputs when they're, unstructured.
I think just to add on that, regarding will hallucinations ever go away? I don't think so. At least I don't see a way with the current architecture and technology for it to go away, because essentially it's a fine balance. Like when you train these LLMs, especially like now, you train them in post-training for agentic tasks, using tools along trajectories of 100, 200 interactions with an environment. You want them to create things. You want them to hallucinate in a way. You want them to make things up. If you just wanted an LLM to reproduce exactly what's there, then I don't know, why not just return search results directly without summarization, without abstraction from the LLM. So they need to be flexible. They need to be creative. They are statistical. And that makes them very powerful because they can exactly express that fuzziness that we couldn't express with deterministic software before. But it also increases the risk of them making things up or behaving in ways that weren't intended for this specific case. And I think that's not gonna go away anytime soon.
I think it's a really great point that there's a tension that if you want a machine that's creative, then that's fair enough. That's a really good point. I was curious because, yeah, indeed, like we don't have verification layers for natural language, of course. And that was the domain of the field that both of you guys maybe worked in, or maybe just you, Miriam, like natural language processing was kind of like interested in this. And I wonder, like, what kind of practical deployed verification layers, like, I mean, I know that these are proprietary, so I'm wondering, like, can you guys say something about this? Because I think for software, the people who are involved, we can imagine, right? Like, what are these verification layers? But do you think that you could share something about what kind of verification layers do exist for certain specific cases?
One method from the, let's say, older NLP days is natural language inference. So that's been around for more than 10 years at this point, where we had data sets, and then later on when transformers came around, models were trained on that to have one sentence and another sentence, and then have a model predict if the relationship between the two is entailment or neutral or contradicting, actually. And there are tools today that claim that they're detecting hallucinations by looking if it's a neutral relationship or a contradicting relationship. We say it's a hallucination. Now, the difficult thing about this is that the data sets were very compact, let's say. So it was always one sentence and another sentence, and then we make this judgment. This is not how today's Gen AI applications work, right? So we have thousands of tokens on the input side, and usually hundreds of tokens on the output side. So it's not that easy to just say, the one part is the boy plays with a ball and the other part is the man goes to church. Okay, that's contradicting. It's a hallucination. Yeah, okay, that's easy. That makes sense, right? But in real life, hallucinations are much more subtle than that. The texts are much longer. So while NLI is a tool and it was useful and very valuable back in the day, basically, today we need to think about hallucinations very differently.
That's true. Yeah. I mean, I guess academic domains have this quality that like we have toy problems to make progress, and that at some point may become something useful or never. And I guess so far this is never. I guess for the listeners who don't know about this, natural language processing was this field that had this idea about computationifying a lot of ways that we think about language, both from the point of view of linguistics and philosophy. And we build a lot of different tools and we build a lot of data sets, but it turns out that it's extremely labor intensive to build these data sets for statistical models to work. And a lot of these directions were basically abandoned, right? So I think that NLI, or like natural language inference, is also this direction that like, okay, we proved it that we can do it on the sentence level. If someone is interested now, they can build like an actual data set that's actually useful, and no one has done it. I think that's kind of the way I interpret the situation.
Yeah, I think that's very interesting the way you frame it, because essentially what we say we see is like, yes, any system based on these old models and data sets just doesn't adequately reflect the complexity of what we use LLMs today for. But we still see many big software cloud providers advertising products exactly built on this technology as their solution to hallucinations. And that's something where we'd say that's maybe a problem of the entire industry, that it's moving so fast currently, and nobody actually takes a break to check kind of how well does this actually work. Like everything is very very hype driven. Here's the next thing and the next thing and the next thing. And on the surface, it looks amazing. There's this whole like narrative behind it of the computers are intelligent now and they can do all of this work and we are all going to be out of jobs or we never have to work again, depending on how you want to look at it. But most of what gets advertised, what people talk about, be it on LinkedIn, X, even in the B2B context, is often just like, oh yeah, this looks amazing in a demo. On the surface, it looks amazing. But never really is there anyone who stops and looks underneath the covers and says like, oh yeah, but actually this doesn't really work. And this is, I think, how you can now end up with like multiple competing products using a very antiquated technology by this point to solve an issue, in air quotes, that the technology isn't fit to solve at all. And that's, I think, something we're aiming to tackle with what we are building.
Okay, let's break it down a little bit. Do I understand it correctly that there are two sub-problems? Like one is definitely detecting. I think that's what you guys were saying, right? Like the detecting whether there's hallucination. Okay. And for this particular problem, noticing that the model has hallucinated and also specifically in this extrinsic sense, so that like you gave it like some sort of data. Do you guys know whether there is state of the art right now that is somewhat useful or it's pointing in a direction when this may be useful in the not so distant future?
So if we go to like the more modern approaches, I would say one of them is definitely LLM as a judge, meaning that you essentially pass the data that you gave to the LLM to another LLM and ask it to judge the output. The problem with that is that oftentimes people ask, like, how grounded is this output on a scale of 1 to 10, for example? Okay. The LLM doesn't have it's not calibrated, essentially. It doesn't have a good sense of how grounded something is on a scale of 1 to 10. Also, for the user, it's not that useful. If I see a wall of text response from an LLM, and then it has a tiny score on top that says, this is 7 out of 10 grounded, I'm like, okay, great, but where are the errors? So what we're doing is actually we kind of extended this approach. We went to agent as a judge, meaning that we have more of a system judging the LLM's output. And another thing that we do, which we think is really important, is be specific. LLMs can always gloss over so many things, produce something very hand-wavy, and then it's not that useful, and also lower quality. And what our system does, it actually highlights the exact span in a text. So this exact sentence maybe is hallucinated, or this exact sentence doesn't follow the instructions that you gave in the prompt. And this way you get a better detection, and also the results are much more useful.
With this kind of approach that you guys have, that like I will ask later from you guys when you are more you have more money and more revenue, and it's and you're already at the third iteration of what you're doing, and I can ask what happened last year, and I will ask how did it work now. Exactly. But what I'm very curious about now is that I suppose that you guys are meeting your clients, learning about their use cases and stuff. And like, so first of all, I'm quite curious about like, do you guys find it's quite important that you make customized specific solutions for certain people? Or do you feel there is a potential of moving that to a general solution? How do you guys see this?
I think both. What we're aiming for is a product that is customizable. It is extremely important to customize the hallucination detection onto every single use case, even if it's the same customer and they have 2 AI products that they want to use our product on. You have to be very intentional and very specific about the context of the context that the tool works in, specifically about what are mistakes that I, as the person who's responsible for this Gen AI product, would consider a hallucination? Especially when you think about different domains. In some domains, as we talked about omissions earlier, right? In a pharmaceutical domain, for example, omitting a side effect of a medication is very bad and definitely unacceptable. If you're working in a domain, let's say journalism, and you want to summarize a long article. Of course, the summarization is going to omit some details, and that's exactly what you're looking for. So that's not a hallucination at all. So that's a very obvious example on how you have to customize the detection in order to serve different use cases and to be useful for different use cases. And we aim for our product to be customizable by the actual experts in the field, so they can go and see what's happening in my Gen AI application and what are the failure modes that I want to cover and that I want to prevent.
That's really nice. It makes a lot of sense for sure. I think it's a really nice idea that like you guys are thinking about it this way. Something that came to my mind is just because, I mean, feel free to not answer, but like because I don't know if you guys are like focused on this to any extent, but like, at Human Future Hub, we are really interested in education, and not only like AI literacy or like teaching people about AI or whatever, but literally the educational system and how it is affected by AI. And I often worry about, like the hallucinations with regards to material. I mean, that's just one of the issues or whatever, but I was wondering whether you guys know anything about this, because I think it's like one of these very big domains where hallucinations might have an impact, and you guys know a lot about hallucinations by now. And I was wondering, like, have you guys read about this, or have you guys talked to any educators, and do you guys know anything about the impact of hallucinations in this kind of grander public things like education?
Maybe that's a very broad idea of education, but we recently looked into the Google AI overview that's now on top of every Google search that you do, right? And just recently, an article came out actually in the New York Times that pointed out that, first of all, a lot of the information that is given is hallucinated, as you can imagine. And even more of that information is ungrounded. So, they don't provide any actual source. So the information that's given in a lot of cases is just drawn from the world knowledge of the LLM. Yeah, as I said, it's a rather broad application of the term education, but I think on a daily basis, right, we all educate ourselves using Google, and we have been doing this for decades, basically. And we keep on doing this now, but now with this new feature or product by Google, basically, that's the AI overview, feeding ourselves information that's either ungrounded or, hallucinated, and then just taking it as facts, basically, is dangerous, right? And it's served to us as if that's just, you take it, this is your information, and go. And that's how a lot of people use it. And I think that's very, very problematic. And it takes from us this whole, let's say, brain effort of actually researching something, because it presents itself as, I'm done, I did it for you, but it's not necessarily correct.
Yeah, I see what you're saying. So like it's kind of like, it's like Google is like compromised now. Like Google compromised itself in a way, right? Like it's just like, it's a very good point, yeah. Like, because we are so used to the feeling that what we find on Google was written by a person. I wonder, for example, like in the case of companies, to not get into just like completely random social issues, that like, I'm wondering about the feedback loops. Like there are two feedback loops that I'm wondering about. One is when, as you were saying, the pharmaceutical company is particularly interested in not missing side effects, right? For example, or like not citing the wrong side effect, which is also kind of crazy, I think, to scare people off your medicine. I wonder, like, when you detect these things, like, is there a way to feedback in terms of improving the model?
That's actually a very interesting direction that we're looking at right now. So if you have an agent, let's say, that calls tools to achieve a task, let's say we have an agent that researches a topic and then produces a blog post for content marketing. This agent runs for a while. It uses web search. It collects data, essentially, and then it produces the blog post according to the style guidelines. Now, there's so many things that can go wrong. Like, it can pick outdated information. It can hallucinate information that was never found on the internet. It could also just not follow your style guide or take the topic into a direction that you didn't intend to. Or maybe it positions your competitor's product as the ideal solution to the problem you're talking about. So a bunch of things that can go wrong. And this agent works, and then somebody has to review the output and decide if it should go live on the website. And what we're looking at into right now is, can we steer the agent mid-run? So because we're running our issue detection, let's say, not just hallucinations, issue detection on the trajectory of this agent. For every tool call, every output of the agent, we can say, oh yeah, that's actually maybe the wrong search term, for example. That's the wrong direction. And intermittently, you can feedback these findings back to the agent. So basically, the agent runs a bunch of searches and has accumulated some material, and it says, okay, I'm done with my research. And then it asks, hey, can you help me out? Can you give me some feedback? Can you steer me into the right direction? Is this actually all the research that I was supposed to do? And then our product might say, oh yeah, actually this part is good, but here you missed this sub-problem that the article was supposed to talk about. There's no material, so go ahead and fetch some more for that. Then it could go on to write the blog post, for example, and then ask for feedback. Hey, do I follow the style guide? And instead of just getting a response of like, oh yeah, this looks roughly right, or oh yeah, there's some issues, here's what they are, our system could exactly tell the agent, hey, in your blog post, in this position, this formulation actually doesn't comply with the style guide. Please change that. And then the output gets better and better and better. And I think adding this depth of verification through steering the agent prevents something like, I think what people now call work slop, meaning that I get a blog post, like let's say I'm a director of content marketing somewhere, and I tell someone or somebody in my team writes a blog post, and they just send me a completely AI generated output, very long post, 2-3 pages, whatever, and now I have to review it, and that puts the burden on me to review the AI slop that was produced before, which is not acceptable in any case. But how can we get that output to a much higher quality and reduce the review burden? And this is where steering the agent mid-run might help to do that.
Okay, it's really cool to hear. Like, it's very similar to what you guys were discussing in the beginning of, like, it's so nice that for software we have all these things like tests that they basically do the same thing on an extremely high level. Right. And it's also nice because I think it also relates to what you were saying about the customizability, right? Like if the domain experts like actually care about the system and keep customizing it, then they actually get like a better result in this sense, for example, that they improve the agent. So, I mean, that's really nice, I think. And I was wondering about the other feedback loop, which is when the company populates their own knowledge base with the outputs of LLMs, right? I got reminded because of what you were saying about Google, that how much do you read in Google that was generated by a machine, for example, Gemini, that answers you anyway on Google, you know? So like, is this an issue in companies or not? Because on a societal level, we always talk about this. But is this a scenario in companies where they produce material that was in total or partially produced by LLMs, and now they are digging themselves into a polluted information environment? Does it happen?
I would say not yet, or I would say we have not seen that yet. I think the customers we work with proprietary data that's very well maintained for exactly that reason. I think data heavy companies have always been aware, in my opinion, that their high quality data is their capital. So that's really something they safeguard a lot. So if you think about the legal domain, for example, of course, all these court files and the court decisions and the laws and all that, that's extremely valuable, curated data that they make sure stays on a high quality level. But of course, what you're saying makes sense in environments where data maybe isn't the capital. When you think about a knowledge bases in companies, when it's about, in internal knowledge hubs, basically, and something like, let's say, a policy or, blog posts, right, that people wrote a year ago or whatever. Of course, they go into the database. It's part of our portfolio now. So next time I search, has there ever been a blog post about this and that topic? Of course, something that was AI generated a year ago might come up. So I see this problem. It will happen. So far, the companies we work with don't run into it yet, I would say.
Yeah, it's like a matter of adoption, I suppose, right?
Yeah. I'd say again, maybe we can see the coding use case as kind of the front runner in adoption, and also as a good use case to look at to see where things might go. So if we look at the coding use case, many open source projects now have the problem that they drown in pull requests and in code changes that people submit or in issues that people raise. And many of these issues look very well researched on the surface. Let's say security issues, for example. There's 50 security issues that come in every week. And before that, it might be one or two a year or something.
Yeah.
And from these 50 issues, they all have like a 2,000 word explanation of what the issue is and how it can be triggered and what the impact might be, and then how to fix it potentially. The problem is that in many cases, these aren't actual issues. They are things that an agent misinterpreted, and a user used this agent to just autonomously submit these issues and pull requests. And this means that the open source maintainers don't know anymore how to properly maintain their project, because they don't know if an issue is filed, is it actually a real issue, or is it just something that was made up that is AI slop, essentially, and doesn't quite pose a problem, actually. And distinguishing between the real issues and the hallucinated slop issues is very difficult. So if we look at adoption down the line in the workplace and other fields, if we don't build these reliability systems right now, they might very well face the same problem.
Oh, thanks so much. And it was actually a point that I never thought about, that like for people who are not in the tech industry or in the software industry, like looking at the software industry is such a good way to know what's coming in the future, because we always adopt everything. Because as you guys were saying, we have like all these many decades of building tools that in principle keep us safe from destroying our own infrastructures. Whether they do or not, that's a different question. But like at least we may be able to protect ourselves from slop. But it's true, like people should, if they have the ability or time in the world to look at like how we are progressing, they might get a sneak preview of their future. I think that's a very good point, actually. Maybe the last kind of topic before I move on to just asking you whatever you want to talk about is that I wanted to ask, you guys were mentioning a lot about the unreliability of these systems, that it's inherent. And you were also saying that a lot of the problems that come from LLMs, you guys are solving with LLMs nonetheless, but then just kind of using them differently, multiple of them verifying each other's output. And I was thinking whether you guys find that having people in the loop and then just reducing their burden. In the extreme scenario, there's always a person to check the output of LLMs, but then why do you use an LLM, right? Like now you have two people doing the work of one. So is there like some sort of asymptotic solution where like people are still involved, but they actually just not so overburdened? What do you guys think, or is this how it goes?
Definitely. I think for a lot of businesses, having a human in the loop is non-negotiable. And in most cases, I think that's the best idea. For a lot of things, we should not just rely on LLMs for obvious reasons that we've been discussing, right? But also for the question of responsibility and just making sure someone oversees what the LLMs are doing. But to make this extreme example, as you were saying, now if we just generate something sloppy and then a person reviews it, you might as well just do it from scratch, because you're not saving any time. But if you think about this agent that Mathis just described, that reviews itself over and over again and manages to go to a place that's already pretty good, then the review step of the human might just be a check, a check mark basically, right? To yes, double check what the LLM did, but not have to basically rewrite the whole thing. So definitely there's time to be saved here, and also brain energy, brain capacity. Put the starting point a lot more to the front, and then just carry it manually over the finish line, basically.
Okay, and this is the approach that you think that you guys or the industry is more or less taking. You said that you feel like it's extremely important that the human is somewhat in the loops in some way. So this is kind of the status quo, and then it's more like the augmentation that you build around these people who are domain experts. That's kind of the thing, right? But maybe this is the wrong way of putting it, but...
No, I think I agree with that. I would strongly distinguish, though. There's a lot of storytelling around we can't rely on LLMs anyway. You have to double check everything anyway. And then it's kind of wrapped in this whole gift wrapper of AI literacy, to put all the responsibility on the human reviewer in the end. And I don't think that's the right approach either. I think we have to get to a point where we can verify and produce trustworthy LLM outputs, but of course still, have a look at it, just like we would have a look at output from, let's say, a more junior team member, or even our own output. If you produce something and you're about to hand it in, of course you're going to double check if you did it right. So of course, some checking, some verification is totally fine. It's actually what we've been doing forever and we should be doing, but not, to start at a point that's most likely slop or not trustworthy and then get it all the way to a good point. That's not how it should work.
Thanks so much. I got everything I wanted out of you and more, because you gave me a couple of surprising answers. So that was really nice. Thanks for the first podcast episode. This was great. I'm very happy. Thanks so much. I love you guys.
Bye.
Thank you so much for listening or watching to this episode on whichever platform you did. We're so grateful to be able to bring that valuable information to you. Give us a shout out in the comments if that was valuable to you, that was interesting. If you have any more questions, we are very happy to follow up on that. And I'm sure Ákos is going to find answers. Please follow us on all possible platforms. We are expanding our presence. Check out our Substack. Please subscribe if that was interesting for you, because we are going to have more and more guests and more episodes, but also we produce our own content, articles, points of views, analysis, and we're really happy to hear from you what resonates with you in that space. We also have open sessions online or in Berlin or in Munich, so go ahead on Luma or Meetup and subscribe there and check out the events near you. And if you would like to collaborate with us, also give us a shout out. All the lines are open. Check out Blue Guardrails at blueguardrails.com, and of course Human Future Hub at humanfuturehub.org. That's org. Thank you so much, and see you next time. Bye.